So here we're going to try and decide for each of these three graphs what kind of symmetry they have, if any. So the three symmetries that we look at are with respect to either axis, the x-axis or the y-axis, or with respect to the origin. And so for this graph one, let's look at the x-axis first. So you can think about this very literally, and you can also kind of eyeball it, and it sort of depends on the person, like if you're able to sort of eyeball it. But the x-axis is, of course, this guy right here. Let me actually maybe make that a little bit more emphasized. See if I can do this. Hello? Well, that's fine, I guess. Okay, so we want to know if I take any point on this graph, does it have a corresponding point across the x-axis? So for example, with graph 1, so if we take that point right there, looks like it's at -6, 5. So -6, 5. Does it have a point? So this is kind of the eyeballing, kind of down here-ish. No, that's not a 5. That's at 3. I'm crazy. Okay. So does it have a point down here, right? Like directly across, same distance away, but like down across from the x-axis. Or you could think of it like if you reflected this graph about the x-axis, would it basically stay the same? The answer to both of those questions is no. So we're not going to check symmetry with respect to the x-axis. I'm just going to go ahead and put a little no next to it, but you wouldn't click that. So the more literal way to think about this is that if you pick any point, so it's a 3, on this, let's just get rid of that, on this graph, then if you reflect across the x-axis, or think of the symmetric point that you, quote, should have, it would be -6, -3. So the x-axis, it's maybe a little counterintuitive, but it's if you take any point xy, and then you also get its corresponding point across the x-axis at same x, but change the sign on the y. So can think of that as a -y. So in this case, it would indeed be -3. Does that point show up? Is it actually on the graph? So -6, -3 is not on the graph of this. Okay, so maybe we'll just do x-axis for all three of these and then go back and talk about the other things. So then for our circle, if I pick a point, I'm going to see if I can find one that looks like it's right on a grid line. Like on a corner. It looks like this one's at 4, 3. So it's approximately 4, 3. So going across then the x-axis, oh look, there we are. And so it should be 4, -3, and yep, that looks like what we've got. And if we pick any other point on this circle, we're going to get its corresponding right directly across from it. If we reflect across the x-axis, we're going to get a corresponding point. So this one is symmetric with respect to the x-axis. Okay, so then finally graph 3. And so graph 3, if we pick any point on this graph, we can see that we have a corresponding point directly across the x-axis. And so it looks like this one, I kind of have covered it up. It looks like it's at -5, maybe it's, I don't know, like -2.1-ish maybe. And then I've got a corresponding point, same x, but now opposite sign for my y. So these two, graphs 2 and 3, are symmetric about the x-axis. Graph 1, though, is not. Okay, so now let's switch gears a little bit and talk about y-axis. So I'm going to erase a bunch of this stuff. So now we're going to focus on if we have symmetry about the y-axis. I think that's a lot easier to notice or look for because we're kind of used to that. Like we have, as humans, we have symmetry about our y-axis in a way. So symmetry about this vertical line, so that you can think of it as like a bilateral symmetry. So then here we're taking any point. Let's see, maybe I'll take this one. It looks like this one's at 3, 2. This one, this graph scaled a little funky, but that's okay. 3, 2. So then if we go across horizontally, across the y-axis, now we're thinking of almost reflecting about the y-axis, and so the corresponding point would be at negative 3, 2. Keep the y the same, but change the x coordinate sign. And you notice I just kind of plotted a point out in space. This red point right here, that's not on our graph. So we're done. This is going to be a no for the y-axis. But sort of the technical definition, I'll try and squeeze it in down here, is you have your xy point, and then you're looking to see, do you have negative x, y for the y-axis one? Okay, so then for these other ones, if we pick a point on this circle and kind of think of reflecting across the y-axis, we do get a corresponding point, and so we can even look at the coordinates just to double check. So it looks like this is at 3, 4, and then we have negative 3, 4. And so any point on this circle, I'm going to find its kind of partner or corresponding point going directly across. So this guy is symmetric with respect to the y-axis as well. Okay, so then let's look at graph 3. Graph 3, there's only really, it's just this point at the origin that if you kind of do this reflecting business that stays the same. Otherwise, like it's totally empty over here, right? So this point that's at negative 4, 2, and I didn't really go far enough, but there's definitely not any point over here with positive 4, 2. So this is going to be a no for the y-axis for graph 3. All right, almost done. So now we're going to think about the origin. And let me see if I can kind of, these, my little definitions here. So can I make these like, I don't know if I can. Never mind. I was trying to like move them up because things are getting a little crowded. So for origin, the kind of literal definition is that you take a point xy and change both signs. And when you change both signs, you're now looking at it diagonally across the origin, 0, 0. So let me see if I can kind of squeeze that in right here. So if we have our xy, if we're symmetric about the origin or with respect to the origin, then we should get a corresponding point at negative x, negative y. So you change both signs. So for example, let's take maybe this point right here at the top of this little hill, this little relative maximum. So it's at 2, 3. And we need to see if we have a point that's at negative 2, negative 3. So here's negative 2, negative 3. Oh, look, there it is. And that's a relative min, kind of opposite. And so here, I'll put this in negative 2, negative 3. And if you draw a line, the line segment connecting these two, it's going to go through the origin. So you're sort of traveling from your corresponding point through the origin to the other point. And so again, like any point I pick, if I draw a line through the origin to the other side, I'm going to find a corresponding one that has the same coordinates but opposite signs. So this actually does have a symmetry. It's origin. Okay, so then graph 2. So this one, this circle, if you imagine taking any point and going through the origin, you're going to get a corresponding point, right? So we're actually drawing a diameter because it looks like this circle is centered at the origin. Any circle that's centered at the origin is indeed going to be symmetric to all 3 of these. And so again, any point I can find its corresponding point diagonally across the origin. Okay, so then for graph 3, if I pick some point, maybe this point again that's at negative 4, 2, if I change both signs, that would be positive for negative 2, which would be right here, and there's clearly not a point on this parabola over there. So this is going to be a no for the origin. Okay, so that's all the things for these 3 graphs. A couple of pointers. Remember that you'll never have a graph where you've got exactly two of these selected. So it's either going to be all three, like this circle, or it's going to be just one of them, like our graph 3 or graph 1, or it's going to be none. You're never going to just hit like two of them. Because basically, as soon as you have symmetry with respect to two of these, either both axes or an axis and an origin, you automatically it'll also be symmetric to the third one. And you can try drawing that out to try and prove me wrong. And that'll actually kind of, I think, help if you just try and draw like different graphs, like try and draw one that's symmetric with respect to the origin, or whatever. That'll actually be really helpful.